So, hi all, this is Lakshmi working as assistant professor in the Department of ECE at SNSCT. So, today I'm here to discuss about the lecture series on electronic circuits, and the topic which I'm going to discuss is about rectifiers. So we all have heard about the term rectification. So this is a process of converting AC into DC. So the conversion of alternating current into direct current is called as rectification. So we must know what is alternating current and what is direct current. So here you could see the figure which I have given. So alternating current, which means the name itself indicates that it periodically reverses its direction. So which means positive, negative, positive, negative. So we could see this here. So the process of where it periodically reverses its direction is called as alternating current. Whereas in direct current, we could see that it is constant with respect to time. So this is the basic difference between alternating current and direct current. And there are two types of rectification. So one is half wave rectification and the other one is full wave rectification. So before going into the concept of this half wave and full wave rectification, so we must know the purpose behind this process. What is the need of rectification? One real-time example where we use this process, we must know. So first let us discuss that and then we can go into the concept of this half wave and full wave rectification. So here, so most of the electronic devices works on a regulated DC power supply. So one example is amplifier. So this DC voltage has to be obtained from our AC supply. So at our home, we receive AC power supply, so which is 230 volt and the frequency is 50 hertz. So we all know this basic information. So say for example, if we receive the alternating current which we receive is directly given to a laptop charger. What happens? So when we directly give the AC supply 230 volt directly to our laptop charger, it will directly to our laptop, it will burst. So for that purpose, we have a thing which is called as DC power adapter. So all have seen this, right? So this is our laptop charger. So here I have a DC adapter. So inside this DC adapter, so we have a rectifier circuit. So the purpose of the rectifier circuit is that, so when we plug in, so we receive AC supply, right? And it is given to this adapter. So where the process of rectification is done inside this adapter and then it is taken as output to our laptop. So this is one example. So I have quoted here. You can look at this figure. So here it is given that initially the 230 volt has to be stepped down using the step down transformer. So according to the rating of the transformer, the 230 volt would get reduced and then it is given to a rectifier circuit for the conversion of AC into DC. So output of that circuit will not be a pure DC. So to remove the AC components present in that DC, we use a filter, and then in order to provide constant power supply, DC power supply to the electronic device, we use the voltage regulator. So that is the rectifier example here which I have given. So now let us discuss about the half wave rectifier. So half wave rectifier, it will allow only half of the AC voltage signal and it blocks the remaining half of the AC signal. So here we could see the circuit diagram. Initially the AC input signal is given to a transformer where a step down transformer so that it will be reduced and then it is given to the diode. Here the PN junction diode is the main element which is acting as a rectifier which converts AC to DC. The reason why we use diode here is the unique property of the diode is that it allows current to flow only in one direction. So that unique property made the diode to function as rectifier. So this will conduct current only in forward bias and then it will not conduct in reverse bias. Hence, during the forward bias, positive half cycle it conducts and during negative half cycle it does not conduct. So this is the output of the half wave rectifier. So next is talking about full wave rectifier. So here in full wave rectifier, we use two diodes so that we get the output at both the half cycles, both positive and negative. So initially during the positive half cycle, the diode D1 will be in on condition, D2 will be in off condition. So which means here the first half of this coil center tapped transformer, first half will be positive, and then the diode will D1 will conduct, and in the second half this point would C and B will become positive, and diode D2 conducts, whereas D1 does not conduct. So by this process we could get the output at both the half cycles of the input. So this is how the half wave rectifier, full wave rectifier output looks like. So this is the AC input. So we could see that the DC output voltage at both the half cycle. So today's assessment is discuss the working principle of rectifier. So as I told, the main component which acts as a rectifier is our PN junction diode. The unique property of the diode is that it allows current to flow only in one direction. So this concept of the diode made it to function as a rectifier. So this is the principle, working principle behind the rectifier process. So thank you all.